So, section 2.3, we're just working on the first three of these today. I'm hoping a lot of this is just review. So let's take a look here. Give you a second to jot this down if you would. So if you can think of a function as just this box, that we get to pick what we send into the box. Call that the independent variable. It's independent because we get to pick it. So here, they're sending a 4 in. This magic box does something and multiplies it by 2. And then it sends an output of 8. So no matter what value we send to it, it's going to multiply it by 2, it being the magic box, and send out twice that much. Notice, though, here's the big deal. For any one value, I'm only getting one output. For one input, I'm only getting one output. If I get more than one output, it's not a function. It's something, but it's not a function. So what we get out as output is known as a dependent variable, and that's what the function produces. We call it y. It could be f of x. It could be, it goes by several names, but that's how that works. Next thing we're looking at, domain and range. You don't have to write this down. Just look at it with me. It's in the book. So, domain is just what values can x be? Can I pick any value for x? If I can, then the domain is all real numbers. Then what's the range? Well, that's the values of the y that are produced from my x's. So domain, what x's can we choose? Most of the time it's any value for x. Y, what values do we get? Sometimes that's any possible value. Not always, as we'll see. Look at my little y equals square root of x. Is there anything x can't be? Can't be negative. So I would say the domain for that is what? Where would it start? 0, and it can be 0, so I'd put 0. And it could go all the way up to positive infinity. How about my y's? Can they ever be smaller than 0? No. So my range would be from 0 all the way up to positive infinity. So that little equation right there is one of the parent functions that we're going to look at later on, the square root function. And it has all sorts of varieties to it, but the domain and range are both from 0 to infinity. So notice we just cut out a whole bunch of numbers there. We restricted the range and the domain. Everybody good so far? Okay, like I said, I'm hoping this is a review. You don't have to write this down. Just think with me. We are just assuming that if nobody says anything, if the problem doesn't look weird, and weird we'll talk about here in a second, if it's not one of those exceptions, we're just going to say the domain is all real numbers. That's just where we're going. The domain is all real numbers. That's like you're innocent until proven guilty. That's what we're assuming. Now, what are the exceptions? Well, those are down here.
At this point, we need to stop.
We got 2 exceptions. There might be more later on, but right now, we're going to assume that the domain is all real numbers, except when what? We get a division by 0. Look right here. What can x not be right there? 0. X could be negative 2. It's okay to have a 0 on top. That's a good question. I just can't have one on the bottom. Right? That's exception number 1. So the domain for this thing right here would be what? X not equal to 0. Any number other than just 0. Second exception, I get a negative under a radical that's an even root. So it could be the square root of something. It could be the 4th root of something, the 6th root of something. So if the number outside the radical here, something like this, 4, that says the 4th root of 5. Is that okay? Yeah. But if I get the square root of negative 3, like right here, I can't have that. Right? Because it's an even-powered root with a negative under there. On the other hand, look at my last example here. The cube root of negative 4. Is that okay? Yeah. What's the cube root of negative 64? Negative 4. Thank you. See, I can have that because we've got a negative times a negative times a negative. And that comes out to be negative. That's fine. It's just when it's even powers that we have to worry about that. So stop right there. See if that makes sense. And we're going to use both of these exceptions here coming up in just a minute, possibly to your dismay. Let's go to, is this a function or isn't it? Give you a second to jot this example down. So look at example 1. Function m there. Say relation m, I should say. Is that a function or not? Peyton? Yes, why?
Because all of your x's give you different y's.
Yeah, I've got different x's here. As long as I have different x's, I'm golden. Notice each one of those x's just gives me one y. All right, thank you, ma'am. How about f? Henry?
It's not.
How come?
Because there's 2 tens.
Yeah, I got 2 10s, and they're giving me different y's. So the same x is giving me different y's. Not a function. It's a relation, but it's not a function. So there's one way they're going to ask it, and some of the homework problems are just like that. Another way they could ask it is by giving you a mapping or a table. Notice that's just exactly like giving you the ordered pairs. This thing on the left is called a mapping. It just says 4 maps to 100, 6 maps to 200, 7 maps to 200, and so on. What's the domain there? Parker? Here's my x's over here.
6,
Mm-hmm.
7,
Yep. That's it. What's my range? Evelyn?
100,
Yes, ma'am?
200,
Mm-hmm. That's it. Okay? Is that a function?
Yes, sir.
Some people are saying yes, some people are saying no. Bailey, why do you think it is?
because the x doesn't repeat, and some of them can equal the same y.
Okay, the x doesn't repeat. Does each x give you just one y? Yeah. It just so happens two of the x's give me the same y, but that's okay. Remember, as long as one x gives me just one y, it's a function. Look at the little table. What's the domain? You have not picked on. Brenna.
Maybe 5, 0, 5.
Yep, thank you. And what's the range? Elijah.
2.
That's it. Now, thank you. Is that a function?
Yes.
Yeah. Each x only gives me one y. It just so happens they're all the same y. So what would that look like if I graphed it? It would just be 3 dots horizontal on the graph. So far, so good? There's problems just like those two. C. If they give you a graph, and they're going to give you some graphs, I'm going to say, is this a function or not? If you already know what the vertical line test is, don't write this down. That's just a waste of your time. If you don't, it wouldn't hurt to jot this down. Here's 4 examples. Notice on example A there, those red or whatever colored lines those are. Notice each one of those vertical lines is only hitting the point in one place, the function in one place. In other words, there's no 2 blue dots like this. See, if I had this dot right here, now I wouldn't have a function anymore. Okay, so A, function. B, no. I could draw vertical lines all through that thing and they would hit in more than one place. C is just a straight line. Definitely a function. And D, yeah. Now what if it was turned sideways? What if it was going like this? No. For the same reason that the one above it wouldn't be. A relation, but not a function. Okay, they're going to give you something like that. Let's do another one here. Here's this. And this one you might want to jot down. Before we leave this right here, what's the domain of A? Uh, 0. Yeah. 4, 5. What's the range? So, -1, 1, -3. These aren't not in any particular order. And 2. Did I miss one? I think I got them. How about in B? So domain is what? Oh, I can't do it like that. I can't list them.
-4, +4.
Thank you. And it can equal those. So I'm going to put this. See, that's a continuous kind of thing. The range. What's the smallest what's the smallest y can be?
-5.
It's actually 6, I think. It's hard to see. Okay, how about C? Mm-hmm. X can be anything, because I'm not seeing those exceptions pop up anyplace. How about the range? So for a straight line, that's what it's going to be, right? How about D? Is there any value X cannot be? No. So it runs through all of them here. How about the range?
At this time, sophomore, last name starting P through Z, report to 103.
Okay, just didn't want that to go by us. Let's get back to here. So for this one, 2x minus 5. What's the domain? Ask yourself, does it fall under one of those two exceptions? Is there a divide by 0? No. Is there a radical with a, is there a even root radical that's negative? No. So it can be anything. X can be literally anything. What about the range? Is there any value Y can't be? What if X is negative 1,000,000? Well, if X is negative 1,000,000, then Y would be negative 2,000,005. Right? So our range here is going to be the same thing. Now notice something. What if I graph that? What would the graph look like? All right, I'm hearing straight line. Does that kind of match up to example C here? So anytime we've got just a straight line graph, there's our domain and range. Is it a function though? Yeah, it's a straight line. Just like example C. Now, it wouldn't be the same graph, but it's going to be the same kind of thing. So straight line. And it's a function. So there's homework problems that are going to ask you what's a domain, what's the range, is it a function or not? Little 3-part problem. And you all know by now that if you get if you get a problem wrong or part of it wrong, you can go back and do it again, and you have unlimited tries at it. All right, let's look at this next flavor here. This one's a little trickier. When they give you a radical like this, here's the trick. What do we not want under the radical? Negative number. So what I'm going to do is say, I'm going to take what's under the radical here and make an inequality out of it. Don't I want it to be at least as big as 0? That says 2x minus 1 is greater than or equal to 0. If that's true, then I'm okay, right? Because I've got 0 or bigger. It's okay to have 0 under the radical. So then I solve this little guy. Do I have to flip the sign? Nope. I didn't multiply or divide by negative. And so then x itself has to be greater than or equal to 1/2. Because if x were a half, I'd have 2 times 1/2 minus 1. equals what? 1 minus 1 equals square root of 0, and that's okay. Can x be anything bigger than a half? Yeah. So my domain is, it can be equal to a half, so I put this to positive infinity. These are a little trickier, but if you work it like I just showed you, they're not that bad. You just say, how am I going to restrict x? And you take what's under the radical, make an inequality out of it. What's the range? 0 to infinity, because if x is 0, if the smallest I could have is the square root of 0, that means y is going to be 0. All the way up to positive infinity, because as x gets bigger and bigger and bigger, so does y. If I'm going too fast, slow me down. Is it a function? If so, why? Avery, think it's a function? Yeah? Why?
Because it doesn't have negative radical.
No, that's just about domain and range. Domain specifically. Riker? Function?
I don't know.
Okay. Clara? Yes, why? Say that one more time. Is that what, how do we define a function now? 1x, 1y. Is that true here? Each value of x I put in there, as long as it's at least a half, will that just give me 1y? Peyton's saying no. How come, Peyton?
You take the square, if you put like 1 in there, and then 2 minus 1, so you get 1, so plus or minus 1. So you do the,
Oh, we don't have plus or minus 1.
is that not?
See, when I've just got a radical written the way it is, we're assuming just the positive version of it.
Right. But like when you take the radical of 1, isn't it? Square root of 1 is plus or minus 1?
It's just 1. What you're thinking of, and you're right, if I had x squared equals 1, then x equals, now I take the square root of both sides, and that introduces the plus and minus. That's what you're thinking of.
Sorry, just real quick.
Getting back to the question. If I put a value of x in there, as long as it's in the domain, am I going to get back more than 1y? No. So, function. A little trickier. What if I had this? Somebody give me one under a radical. I'll just pick a number here. 64. Minus 2x. Okay? What do? I say 64 minus 2x has to be greater than or equal to 0. It's got to be at least as big as 0. So I solve it, and I get 64 greater than or equal to 2x. 32 greater than or equal to x. Said another way, x has to be less than or equal to 32. So what's my domain there? See, if x gets bigger than 32, I got a problem, right?
0 to 32.
So the smallest it can be, negative infinity. It says less than or equal to 32. If x is a negative number, I'm okay because I got negative times 2 times the negative. So that would be a positive. So it can go to negative infinity all the way up to 32. I get that. But that's how you get the range. Would that one be a function? I'm sorry, the domain. Would that be a function? Yeah. As long as my x is in this domain here, for each x, I'm just going to get one y. All right, so a little trickier. How about this one? I'm just picking out all different kinds of ways they could ask you this on the homework. They're all asking the same thing, but they all look different. So first thing I do is solve for y here. And now the Peyton theorem comes into play. What do I get? So what's my domain? What's the smallest x can be? 0. Can't equal 0, so I do that. It can go all the way up to positive infinity. What's my range? Okay, negative infinity to positive infinity. We okay with that? Because my y's can be negative here. Because that plus and minus thing, plus or minus thing. Function. I'm seeing head shaking. Let's look at an example. What if I put 36 in here?
We need juniors with the last name starting A through C. Please report to room 103.
Plus or minus 6. Not a function because one value of x gives me 2 values for y. See, I've still got domain and range, but not a function.
So if it's plus or minus, regardless, it's not going to be a function.
It can't be a function. You're going to get something that graphs out that looks like this. Bailey. You're going to get like a sideways parabola. It's a relation, but not a function. Questions? Don't want to rush through this. Oh, how about this one? Ian, what do you think? What's the domain?
Would just be negative infinity
To,
to positive infinity.
yeah. If you don't see one of those two exceptions, it's negative infinity to positive infinity. Good answer. So, I don't see one of those two exceptions. How about the range? Same thing. Is it a function? For this, it would help you to see this form, I think. Nope, don't want that one. Nope, don't want that one. There we go. Okay, so if I do this. I'm just going to put some points on here. If x is 1, what's y? If x is 1, what's y? If we were making a table. It says y negative x. So if x is 1, y is negative 1, right? What if x is 4? Negative 4. So 1, 2, 3, 4. What if x is negative 3? Thank you. So then I've got I don't either. I've got this. Don't I? But that's not an equation. That's an inequality. Which means what? It says greater than or equal to. It means all of this. I'm just looking at my original inequality. It says greater than or equal to negative x. So what do? Since it says equal to, I make a solid line, and then I shade above it because it was greater than or equal to. So I'm just going to pick another point. Let's say the point 2, 4. Will that pass the vertical line test? Think about it. If I do a vertical line, y'all, that's going through an infinite number of points. Look at that. All this red is points. No way. No way that's a function. If that wasn't an inequality, it would be. But that's not the graph of a straight line. We got an inequality.
So any inequality then?
I would go with any inequality is not a function. So watch out. That's why I wanted you to see the graph of it. So it's like, okay, I got that. Questions about that one? Okay, one last example. So let me write this. No, not like that though. Not a function. Oh, how about this one? Is there any value x cannot be? Negative 2. Okay, thank y'all. So x cannot, I'm just going to write x cannot be negative 2. It can be any other value. It could be negative 2.000001. But it can't be negative 2. It could be 2.07, but not negative 2. How about our range? This is the tricky part of this one. Okay, here's what I'm hearing. Y'all agree? Think about this one. This one's tricky.
Would it be negative infinity to 0 and then union 0 to positive infinity? Because it can't be.
X could be 0. Are you talking about the range?
Yeah.
Why can't it be 0? Why can my y not be 0, Peyton?
Because to do that, you'd have to make the denominator 0, so that just.
The denominator being 0 doesn't have anything to do with the value of the, well, it has something to do with the value of the fraction, but why can't the whole fraction be 0? Why can't y be 0?
Because a fraction can't equal 0,
Because a fraction can't equal 0. Why not?
because that makes it not real.
What would I divide 3 by to make the whole fraction 0?
0,
No,
nothing,
nothing.
it just doesn't happen.
That numerator's not changing. It's staying 3. There's no value I could put down here in the denominator that would make the value of that fraction, 3 divided by the denominator, 0.
So,
There's no way, I don't care what value of x you put here, that the value of this fraction, the y, is going to be 0. Now, the bigger x gets, the closer and closer and closer and closer. What if x was 20 million? Then I'd have 20 million and 2, and 3 being divided by that. That's a tiny, tiny little number. It's real close to 0, but it's not going to get to 0. It's going to approach it. And in calculus, if you end up taking calculus anytime down the line, you're going to talk about limits, and we'd say, well, the limit of that fraction as x gets bigger and bigger and bigger is 0, but it never reaches it. Interesting. Function?
yes.
Yeah. Because as long as I don't pick negative 2, any value of x I put in there is only going to give me 1y.
Can you give us an example of when it gives like more than 1y?
What if I had? What if I had this?
What's the range then? Is it what Peyton said it was?
Well, you could. I wouldn't write it like
Or just
we
like
had
y
it
is
here.
not equal to 0?
I would just say y not equal to 0. It could be anything else. So that is a function. What if I had y squared equals that same thing? Then I'd have y equals plus or minus the square root of this thing. Here, any value of x is going to give me a positive answer or a negative answer. But now here, x couldn't be 2, right? And this one right here, x could not be equal to 2 because of this. And there's other values it couldn't be also. It couldn't be... Well, what would we do? We'd do that same trick I did before under the radical, and I think you'd find that x has to be bigger than 2. Bigger than 2. So that's not a function. Okay, those are trickier than just those little tables or the little ordered pairs. You've got to use one of these techniques to figure them out. Last thing, this is not a problem. I know from experience that people don't read directions on tests. They just jump into the test and start working problems. And I want you to see the directions ahead of time to make sure you understand them. Because if you don't follow them, I'm going to take points off. So, first one is I want you to work all these out on your own paper.
It's gone.
Okay, so work these out on your own paper. The test paper, please don't write on it, except right up here, you're going to write your name on the test paper. Third one, highlight or circle your answers. I want to know what you really mean your answer is. Don't write me a whole bunch of stuff and then basically go, hey, Ladley, you figure it out. Because I won't. Last thing, show all your work. If you just stick an answer down there and you haven't shown your work, you won't get any credit for it. So those are the directions. I wanted you to see them ahead of time.